Hello everyone, welcome to Bite into Future. Today I'm welcoming my friend Quinn to Stanford to discuss a report written by Stanford.
Yep.
So Quinn, tell us about the paper we are going to discuss today.
Yep, it's a paper or it's a very long report I've been looking forward to. Actually, I have been doing similar things ever since 10 months ago. So for my background, I'm a research engineer in Databricks, and then I'm very interested in LLMs. So ever since last year, May, I was really looking into this area, but have a lot of unanswered questions. So I really want to dig deeper and then start to take my notes about all those unknown areas. I want to know what are the training costs, what are the performance as compared to human.
How many models?
Yeah, how many models?
Open versus closed.
Exactly.
So we have, Databricks research engineer Quinn. We are going to dive deeper into our understanding, reading of this report, and hopefully, by the end of the session, you will get to know the landscape of
Exactly.
the large language model, right?
Yep.
Is that what intelligence level? How many models? Where's the contribution from?
Yeah.
And so that you have a pretty good understanding of what's going on with the large language
Exactly.
model out there. So let's get into that.
Yep, looking forward to it.
So one of the things I was always very curious is, where's the contribution of the AI technology or the research, right? We all know that a lot of the work is done by Google and then the
the
OpenAI.
big techs.
What about the academics? My perception is there seems to be more contribution from OpenAI and the Google of the world than from the research. And then, whether you like it or not, it turns out to be true, right? Most of the work is actually done by the industry, or the progress has been made more in the industry than the academia.
Yep.
However, if you're only looking at a sheer number of the publications, academic area still, there's still a lot from the education, right, from the schools and so on.
Yep.
Presumably, a lot of that has to do with how to test, how to,
Yep.
there are a lot of
sets.
the data sets, peripheral things, right?
Yep.
So there is a data to show that a lot more, until 2014, the number of notable machine learning models came from academia. But after that, most of the work actually came out of the industry. So
Yep.
that's this picture showing us. The other interesting thing is the patents. So I've, just looking at, ever since 2019, I
Yeah.
would say 2020, the number of patent applications just skyrocketed.
It's like exponential curve, very classic.
More than exponential almost, right? It means that people just are paying attention to the patents a lot.
Yep.
At the same time, there is an interesting graph that shows that the model, the number of models is actually tapering off. So we have, roughly speaking, 100,000, sorry, not the models, papers. We have, roughly speaking, 100,000 papers in 2015. And then by 2020, roughly 200,000. So last year and then previous years stabilized at 240-ish. So you can see that there's not much increase last year over the previous year. Instead of a steady growth over the previous 10 years.
Yep.
That's pretty interesting. I wonder why is that, right?
Yep.
Do you have any reading?
Yeah, I can share some observations. So one funny thing to share is that probably we heard from many kind of famous people on the internet from the academy saying that it has been so exhausting in certain months to catch up with the new papers. Probably you also remember there's a period, it's like they always say, oh, it's like change my mind every week or even every day. So that has been the norm last year. So it's like very exhausting, but for me, it's like learning so much things. And on the other hand, in terms of the industry versus the academic sharing, one thing I observe is that the industry is more like taking a lead in terms of developing a new model because they have a lot of budget to burn for training like a bigger foundation model. So in comparison, there's fewer foundation model from the literature. But however, on the other hand, once the models are open source or released, or even in the early research phase that they are open to the APIs, then you see a lot of academic research institutes start to play with them to not just prompting them, evaluating them, but also fine-tuning them, because these are of lower cost, like lower barrier for accessing them, trying them. So we see a lot of great techniques, great outcomes from all those evaluation. And other than that, I would say the research institute actually contribute to a lot of great benchmarks. That's great. So if you if there's a number to show those benchmarks, I think a large portion of them are actually coming from the research institute. So that's pretty great. Okay? It's kind of different characteristics.
Yep, that's sort of from the paper research point of view, right? And then of course we can get into the number of the models, the foundation models. Clearly there is a explosion of the foundation model in the last 4 years.
Yes.
There's a number for that. Actually, we can look into this number right now. Foundation model explosion. 2019 there were 4, 2022, and then 2021 27, 22 72, and then 2023 149. I'm pretty sure that it's safe to bet that 2024 we are going to have even more.
Yeah, over 200 for sure.
Yes. So that's the okay. Anything from your side?
So similar to, actually you have just showed at least 2 exponential curve in terms of publication, in terms of number of models,
Patterns,
exact patterns as
number
well.
of the large language models.
Yeah, similarly as impressive, I would say kind of main big thing I observe is kind of that apply to the scaling law. And then when we talk about scaling law, there's actually different aspects of scaling. It's a very obvious one. People are all talking about how much budget does Google burn, OpenAI burn, how big of a data center they're building for like GPT-6, 7. So that's the compute. And then we should not ignore the data scaling, like how much data we need to accumulate to actually get it trained. And then most exciting is that with all those great compute and data, what kind of performance that we get. So MMLU, probably some people have heard of it. There's also a lot of other benchmarks that we're starting to see this scaling law paying off. So
I think that there are really 2 key things here. One is when you throw in more and more resources, whether compute and the data, is the model performance actually going up, right?
Yes.
Or reached some ceiling? That's number one. Number 2 is, are there enough resources for computing or data, right? Of course, computing is more like NVIDIA's, budget to buy NVIDIA stuff. It's outside the scope in some ways, but data is within the scope, right?
Exactly.
This report actually gave a pretty good, interesting insights into how much data left, at least according to the research. Do you want to jump into that one?
Exactly. So compute scaling, there's a great graph from page, sorry, I don't have the page number, but we can look
That's
it up.
fine.
Yeah. So you can see like a very clear exponential curve that now is like 191 million for Gemini Ultra to be trained. So it's crazy. Yep. And then that's on the training.
And then the GPT-4 is like 78 million. And then the consensus out there is, GPT-5 or next generation of the Google model is going to be even more
Another
expensive.
level, yes.
So perhaps, several hundreds of millions of dollars.
Yeah, and then they're talking about multi-data center training. They're talking about, I think Zuckerberg was seriously talking about running out of power. Like we literally, some data center are draining power and they're out of like a nuclear station.
It's not just Mark Zuckerberg. Actually, a lot of people have been talking about what is the limiting factor, right? Clearly, we couldn't buy enough of the GPU cards from Jensen Huang, right? That has been the case for the last year or 2.
Yep.
But is that really the bottleneck for the next few years, right?
Exactly.
Perhaps it may not be, because at some point there will be enough GPU
more like a manufacturing
supplies,
problem.
Right?
So
it's a more supply demand thing.
Yeah.
But after that, there will be cooling space, the data center and the energy, right? Do we need the nuclear power to power them, or maybe not, or maybe enough? So those are the computing resources. So that sort of answer one question, which is, scaling law. Do we have enough computation for scaling law? I think the graph at least shows that it's going to be a lot of resources, right? It's not going to be.
And people are relatively well prepared for it, because like for the pipeline, for the supply chain, you can easier like prepare for it. Yeah. So the other funny thing is that on the other hand, the research scientist has been saying that language model are more like a compressor, compressing our world knowledge into a model. If we're compressing from something, they're also saying that data is a new oil. So it's more like something that you have to extract from, but there's a limited amount of supply from the data side. So I personally is more interested in that area because data is not something you can easily produce. Probably you can synthesize some of them, but it's not like that easy if you want to get high quality. So in page 52, there's a great section talking about how does the data impact the language model quality. High quality language data and low quality language data. And in those two different tiers, you'll see that high quality language data will soon run out in 2024, probably in that range. Actually, it's exactly this year, which is funny. Yeah. And then for lower quality language data, for example, from the community forums, from all the other discussions, we still have a runway of like 10 years. So not too much of a big concern.
Yeah, on this one, one of the questions I have is that really true that we are going to run out of the high quality data very soon? Part of me thinking is we are actually we are labeling the high quality data as we speak, right? Because, like 4 years ago, you don't see high caliber, high paid people to do data labeling or only do data labeling. The rumor is there is a troop out there, being contracted by the usual suspects, big model, large language model builder. They're having experts, right? Domain experts label a lot of the high quality data. So my sense is, there will still be some way to go for the high quality data. That's one. The other thing is the domain specific.
Yes.
Right. Manufacturing, cybersecurity. I don't think OpenAI or Google of the world has taken advantage of the very domain-specific data because all those domain-specific companies, they themselves have not figured out how to retrieve the data yet, right? So they are busy doing that, cleaning up the data, figuring out how to
embrace
get some of
the whole agent AI first to build a stack, and then they can try to pipeline the data.
And also a lot of the data is in the PDF file in some form factor. In order to extract meaningful data out of it, it's not easy, right? You can always get some data, but can you get a meaningful data? For instance, if the data is in the table, can you get a meaningfulness out of the data? It takes some time. So my view is, we are still going to have quite a bit of the high quality data. However, they are getting more and more expensive.
Yeah, the runway is getting, so then it's actually very similar to kind of how you extract the oil. It's a very high quality, it's so easy that you just like dig a hole, there's like oil coming out. And then later on you have to extract fine grained.
Right. I remember, this was quite a few years ago, I don't know what's the exact state. When the oil price, increased, the people say, oh, let's go to Canada. I was wondering why they didn't go why they wanted to go to Canada. They said, well, it's much harder, but given that.
Yeah, it works. Yeah.
So I think it's the same thing, right? Exactly. I don't think we are going to run out of the high quality data. It's like we're not going to run out of the oil.
Like a trade-off.
But on the other hand, we may need to dig harder. Okay, I buy that.
Probably we can also have a slight coverage about synthetic data, which is like a buzzword recently. So on the other hand, people say that actually language model can actually create a lot of seems good data. So actually synthetic data has been a very hot area in the research. So distillation, you might have heard of that. It's like I have GPT-4 or I have Llama 3. How can I quickly distill its knowledge into data to train my smarter model? So synthetic data is there playing its role. And then people are thinking, oh, what if I just use this to continue this data journey to create even more? And then there's also a discussion in that section about what if you just go to extreme, like give a lot of synthetic data or pure synthetic data. Actually, that will give you some impact on the quality. So I would say it's like you have to strike a very good balancing between them. So synthetic data can be a mitigation for this problem, but it won't be like complete solution.
And so I will share a story. I was talking to the founder CEO of a very famous text-to-image company, and he literally told me that this was a few months back, not most recent. He literally told me that hey, our latest model training was like a delay for 2 weeks because we suddenly found some pollution of the synthetic data.
Oh yeah.
So they have to
rewind.
Not just copyright. I think his concern at the time was more about the quality.
Oh,
right?
I see.
Copyright may be another thing, but anyway. So
Yep.
so they have to rewind. They had to rewind and then retrain. So wasted two weeks just because of the pollution of the synthetic data.
Exactly.
So to your point, it's untrue that large language model can just create the data, then we should have sufficient
I
data.
won't say it's like complete solution, but probably can help. Yep.
Right. Okay, so
Yep. Do we want to go deeper into the scaling law for the performance?
yeah, let's get into that because let's actually make sure that we discuss that.
Yeah, it's a great scaling journey. So I guess a lot of things business-wise, stock market-wise is all kind of driven by this scaling law notion. So we talk about compute training cost, we talk about data scaling, and now with all those crazy investment, like what kind of performance we're getting. So I was talking to Howie about this like a shockingly AI performance as compared to human. And then in page 81, you can see this graph showing all the major aspects in terms of vision, in terms of language understanding, in terms of mathematics, where is it starting as compared to human performance and where it's heading now. So I was honestly surprised to see that actually we are being exceeded in so many different aspects so soon, but also wondering what's your take.
Look, when I look at this graph, I was very impressed, right? Because clearly what it showed that is some of the benchmark that was pretty difficult, we were able to catch, very quickly, right? So at this point, not all of the benchmark, we're above the human level, but, most of them are already pretty close.
Yeah, or even exceeding like or reaching the expert level. Yeah.
Yes. I think so far, I think this is a very impressive graph.
Yeah. Oh, regarding that, I just kind of remind me of like funny story. So the last year has been my experience to kind of explore language models, and then part of the work has to be labeling and then examining the data set itself, the benchmark itself. And I was asked to kind of manually label some of the data. I found that actually a lot of the questions are getting so challenging now. Like ChatGPT can answer it so easily, but me, including my coworkers, it's just like so hard to figure it out. Yes, like when was certain movie released and where something created from certain city, it's just so hard for human to do it. So then actually you start to see some benchmark having the human baseline and also the expert level. And then you see a lot of models actually already exceed the human baseline. Basically mean that in certain area, you take the model actually is performing much better than us as a typical human in the area that you are not familiar with. So it's actually pretty fun.
I think basically you are saying that empirical result has shown that it's the model has been pretty close, if not better than human in many ways.
Yep. If we want to dig into kind of the numbers, it's actually very interesting as well. So if you see different line trajectories, so for image classification, which is the first line that people start to tackle, by the way, that's also where, in my understanding, like what drives the autonomous driving technology-wise, because people see that image classification, object detection started to exceed the human level. That took us 4 years to grow 10% to be exceeding human level. And then now we come to the latest one, which is mathematics. It took 2 years to grow 90%, which is a lot faster now. So this phase has been like on another exponential curve in terms of how fast we're exceeding that speed.
Yep. Here's a graph that shows where models run out of the data, right? This is an example of the MAD. Basically, it's sort of a pollution of the data that could damage the result of the image generation.
The humans start to look a little bit weird as they generate.
After more and more generations, right?
Yeah, like training on its own or training on synthetic data. Yeah.
Yes. So I thought it's kind of interesting to show this graph.
Yep.
Great. I think if we summarize this part, right, the foundation model so far, or this foundation model, there's a scaling law concept associated with it.
Yes.
People always ask, is a scaling law going to run into some limit or ceiling, right? I think if anything, we can take away is from the data point of view, right? There is a concern. It's not necessarily the evidence, or we are running to that like right now, but I think there is a concern. Do we have enough of the data, right?
Yep.
From the compute point of view, I'm actually less worried about. If you look at the GDC conference where Jensen actually announced the B200 or the new technology, I felt like, wow, with this rate of the improvement faster than Moore's law, we're not going to worry about it, worry as much in a year or two.
Yeah.
But at that time, we're going to worry far more about the cooling, the space, the energy.
Yeah.
So that's that. And then in terms of the result, right? Once we put in additional resources, are we getting better result? I think so far the answer is yes.
So far,
right?
yes.
And then there's no
pretty clear.
evidence that it has slowed down. But of course, we'll believe it every time we see the result. But on the other hand, the result has shown very, very good scaling at this point.
Yeah, and just to kind of, so I showed this graph to my friends, and they who don't have technical background, and actually she got worried, just like, oh, humans are being exceeded in so many different aspects. So she raised a concern, like, when will that time come? According to this graph, if you just naively take this as a projection, sounds like this year or next year. So something I want to mention here is that, in my perspective, there's more benchmarks to come. So in the early stage, we think computers can only do calculating of numbers, and then we think it can do image. And then now we're more talking about agentic behaviors. We're more talking about multimodal, and then psychology, a lot of stuff. So I would say there's a lot of benchmarks to be created to measure actually how humans behave. So we are still also in the process of understanding ourselves as human. So I'm not a buyer of like we will be exceeded very soon, but more of a process of can we understand ourselves capability-wise better, and then can we create those to measure it, and then in the end, can we have an algorithm to actually outcompete that?
Yeah, I think today's benchmark, right, or collection of the benchmark, I don't think it's nearly enough to represent human wisdom, right? Human wisdom has such a wide spectrum. Cognitive skill set, creativity, emotional skill set. I mean, there's a so wide spectrum.
Exactly.
I totally agree with you. But at the same time, what this report has shown is that in many of the benchmark, the model is able to catch up very quickly.
As long as you know what's the target, you have enough data and compute, then it's all given to the industry. They figure it out. Yeah, it's a capital problem.
Okay, so maybe we should also talk about the cost of building those models, right?
Yep.
Because it's sort of a, benchmark. We can always scale, but what is the cost? One of the diagram here, it shows that. Oh, you actually mentioned this earlier, right?
The compute cost.
The compute cost. The Gemini 190 million, GPT-4 78 million. What will be, I don't think you would know the answer, but what will be your wild guess about GPT-5's cost?
If I were to give a wild guess, since we're not running out of data, we're not running out of compute, probably we're going to like a multi-data center because we're starting to see Gemini Ultra being trained in multiple data center. So I will still think this trajectory is still moving forward. So give a wild guess of 20 times multiplier. So then probably it's in the order of billion. How many billion? That would be around 4 billion. Yeah, like just a wild guess.
Really? You think the 4 billion cost is pretty close?
Uneducated guess, yes.
Interesting. Yeah, it's kind of fascinating because, I mean, you look at it, right? GPT-4 is only 78, and then GPT-3 is probably, low double digit, right? And now we are getting to 4 billion. Wow, okay, that's interesting.
It's higher than the valuation of so many companies already. Yeah.
Cool. Clearly, there's a lot of the interest in that. Okay, so now we have done with the scaling law, the human versus the AI. Shall we just double click into a couple of the benchmark, right? There are a few key benchmark people watch very closely. One benchmark is this MMLU, right? The massive, what is that?
Multitask
Language understanding, right? So the average accuracy has gone from literally like a 30 to 33% in 2019, right?
Yeah.
This is just 1 year before pandemics. I mean, it's not that long ago, to 90% now. And guess what? A human baseline is 89.8. This is not a not easy. It's the kind of the question is not just a simple mathematics. There are some difficult one. For instance, what are the reasons that the government wanted to regulate monopolies, right? The four choices. It's I actually did a test myself. It's not obvious. I don't think it's kind of a middle school student can do that easily, for sure. So that's kind of pretty interesting. So the other benchmark, which is actually the multidiscipline, multimodal understanding. That is like looking at a graph, understanding what's going on.
Closer to how a human perceive questions.
Yeah. So, the human is at 82%. Gemini is already at a 59.4, close to 60%. GPT-4 is also getting closer to 60%. So one is 80% and 60%. I don't think we would be surprised that GPT-5 or the next generation of the Gemini would be 70 or above, right?
Yeah.
So with the current rate of so if they are able to do that, that means scaling law works. Right?
Yes. Multimodal is definitely one of the big bets for so many companies now. Like Llama 3 is going to have multimodal, and then there's already a lot of open source multimodals fine-tuned from the existing models. And then Gemini, one of the big advantages of it is that, and then GPT-5 for sure will have that. So multimodal, also we already see the gap, and then we already have the data on YouTube, on the internet, so this is like a defined problem, so it will be relatively easier for them to figure it out.
So this one is my favorite, GPQA, basically Google Proof Q&A. So that, which means that the answer, you can't just Google and then find the answer. You have to be, learn some, knowledge, right?
Yeah.
Whether math or chemistry or the physics.
Yep.
And it turned out the latest model from like a OpenAI GPT-4 is actually already better than non-expert human, which means that if you are not take a graduate classes or maybe some, not just the one-on-one, maybe 401 class of the chemistry or the physics, you are not going to pass it, right?
Yep.
But GPT-4 is able to do that. Now, of course, it's still not as good as a PhD. Again, the next big revision from Google and then OpenAI hopefully would bring that from 40% to 50 or 60%. That would be my guess.
Yeah, and then we'll be scared because like if it's doing well on all aspects as an expert level, it's actually will be a lot more useful. In
expert here, we actually mean PhD or graduate students, right?
Exactly.
Not just you take a class for a few weeks,
yeah,
right?
This is not actually like a hobby.
Not like a hobby. Yeah. So this is pretty amazing. So those are a few things. I think you have noticed a few more interesting things.
Fun facts.
Yes.
Yep. So fun facts. A lot of things are coming kind of more like a psychology perspective. So I would say we find similar problem or similar behavior in non-human as well. So besides, first I want to mention something besides what we have in this report, which is also very funny, is that kind of in LLM, they found a very funny technique that if you bribe LLM, say I can give you $20, and then can you do this better?
How?
Turns out
just
prompt it. You give an empty check without anything.
I thought OpenAI has an API to give $20. No, I'm just kidding.
That's not real. Yeah. Actually, now I think GPT-4, because they retrained it, now GPT-4 will play a joke on you. It's like, where is the 20 plus? Give me first, something like that. But turns out initially, that actually works. Similar as like human psychology, where you say, oh, this is so important to me. This is so important for my work. Those prompts turns out to boost the performance. I remember in the paper, they have for Llama, GPT-4 is like on average like 5%, even higher. So that's funny.
And I say things flattering, right? You are such a wonderful
Yeah, you're doing so great
scientist.
job. Yeah, so it's kind of very similar to human behavior. And then similarly on page 145, you'll see LM has a similar, I would say, disadvantage or behavior as human that they're not self-corrector or they're not good self-corrector. Basically mean that if you are given a question, you provide an answer, and then without knowing if the answer is good or not, you are being challenged. Can you think twice? Can you think 3 times? I would say some of my friends will actually perform worse, similar as LM. LM also even performing even worse. So they are not very sure about is this correct or not. So
Interesting.
If they do this twice or 3 times, actually they are performing like 3% worse. Which, yeah, I would say this is actually helping us to reflect on human because those data are collected from human or something from psychology. I think this is like a very interesting area.
So it looks like a large language model is a very, very just like human, right? The strength and the weakness.
Exactly. Yep. So I see you got another fun facts as well. Probably can go over that.
Yeah, the performance can actually vary. This shows that from March 2023 to June 2023, the performance actually went worse. Any take on why?
I would say, technical-wise, my analysis is that we probably, even including OpenAI and many research institutes, we haven't found the best way to actually consistently improve the results, or to make sure it kind of exceeded on all aspects and consistently. One reason being probably we don't have a that's not included in their standard benchmark yet. So they basically don't know that's like degrading. Yeah. The other thing is that just LM are so much hard to align. That's why LM alignments in terms of their instruction following, their performance, or like their chain of thought reasoning are so hard. It's still a very hot topic. So it's coming from those uncertainties from the techniques. Well, people also have some other wild guesses. I saw the Twitter stream where people talk about they see LM being more stupid, and then they're kind of guessing, oh, is OpenAI playing some like secret training cost reduction techniques there to like using cheaper models? I personally don't think that's the case, but kind of people are guessing around that. So it's actually very interesting that some research institutes are actually putting this into action and then measure them over time.
Yeah, I wouldn't be surprised that some of that has to do with the continuous cost optimization, and then this is a part of the result. But on the other hand, I don't think that there's evidence. It's just a speculation.
Yep.
Cool. Are we done with the fun facts?
Yeah, we're done with the fun facts.
Okay, one thing people always, even you and I, when we discuss the landscape, right? What is the landscape? Well, it's about open versus closed models. So there are a number of the, let's see, there should be a page. We'll figure out, there should be a page about the number of the open models versus closed model.
Yes,
clearly, like before 2019, there were more open models, and then 2021, 22, people have less, wanted to keep. But then last 2 years, there are even more open models.
Yes.
I think it seems to be intuitive, right? Because in the long run, we still believe that an open model would have, at least quantity-wise, would have its own space. That being said, I personally think none of the model is open model, because the way I think about open model is they tell you how to build it, where's the data, what's the secret sauce, so that I can go back. Of course, I don't have that many GPUs, right?
Yeah.
But if I have the GPU, I can build it, right?
Yeah.
But there's no way, any of the model, I think the way I look at open model, so-called open model from Llama, Mistral of the world, it's really like, on the Windows, right? You have executable.
Yeah.
So you download the executable, you can run it.
That's
is
not
that
open at all.
Is that an open executable? It's probably not, right?
Yeah.
But I'm good if people continue to call it open model, because at least there's one nomenclature. It's very important for people to know that at this moment, there are not too many. Are you aware of any completely open model?
Yes, there are a few.
Okay.
Yeah. So Allen Institute, they released like a truly open model from, so if we talk about a model, typically there are at least three parts of the recipe. So first, the training data, which turns out most of the player does not want to unveil that. I think that makes sense because on the scaling law, we see that being a huge advantage. Yeah. So training data, and then also the model architecture. That's something you can kind of figure out because on Hugging Face, you can start to see how they're composing that model. And then the next one is actually the model weights. So turns out what most companies are doing are just giving you the model weights that just enable you to use it, but does not enable you to actually debug it, play with it. Actually, technically just give like a one aspect. What's really challenging is that if I want to fine tune it, in order to know how I can continue this training trajectory, I actually need to know what are the original data because the data distribution matters a lot. So that actually draws a huge challenge for the open source community to continue, say, pre-training Llama or other models to perform as good as before. So on those three aspects, I'm only seeing probably less than 10 models or 10 model families. In my mind, currently I can only recall two. One from Allen Institute, the other from probably Apple. They have like a small, tiny model that are fully open source.
That's a tiny one. What about the one from Allen? How big is the model?
That's like 7 billion.
7 billion.
Probably
Okay.
they are training bigger ones.
And then literally you have everything: data, architecture, the weights, everything.
Also, how they prepare the data, what's the pipeline?
Pipeline. Yes, that's true.
That's like 100%.
Only having the data alone is not enough because how do you know the sequencing of the data, right? It makes a huge difference. And how many times maybe you go over again, maybe tokenize it differently.
Exactly.
There are so many different ways, right?
Exactly. I would say open source, still the open source community has this kind of being adopted by many companies as a strategy instead of being like a whole company-wise stuff. So it's really about where they want to balance. They just want to let people use it to kind of level the ground, to let other people not have that much revenue. But in terms of methodology, probably they don't want to let you know. That's like part of their training, their business secrets.
Right. And then the one thing that's important to understand is this graph shows the best closed model score versus best open model or so-called open model scores, right? This is the before, because they did a study a few months ago, as of a few months ago, before Llama 3 was released.
Yeah, which changed a lot.
So which changed the landscape quite a bit, right? If we look at this, the third to the last line, the MMLU benchmark, right? The closed model, 90%. Best open models, the score is 70%.
Yep.
But for the Llama 3, it's already getting to the 80, sort of the plus minus, right? 80, right? Plus minus something I remember. So that is, if you look at this graph, right? Clearly there is a pretty big gap between closed and the open.
Yes.
As of what 2 months ago or 3 months ago, right? And with Llama 3, clearly that wide gap is much shorter. So it's very interesting because on the one hand, people are saying that, hey, close the model, they are going to have a lot of advantage because of the resource they have, right?
Yes.
But on the other hand, it hasn't played out exactly that way, meaning that, because closed model guys have so much resource, their distance between them and then the open model guys is going to be bigger and bigger, right? That it hasn't played out that way. I think the distance is shorter and shorter in many ways in the last 1 year. That's something that I didn't necessarily expect, right? Because I probably was subscribing to the previous sort of the other camp early on. But look, but of course, in some ways this open model is supported by Meta, so it's not fair to say it's a community, right?
Yeah.
It's actually by a $1 trillion company.
Yeah, I have my small take here that I see this more as a cycle where you first see breakthrough, especially for scaling law, the biggest breakthrough much largely coming from the capital investment because the research institute cannot have that much of an investment on that, so they take the lead of 1 or 2 years. After they take lead, they will start to gain huge revenue from that, and then business-wise, they have competitors. Those competitors will try to balance that. So as one of the balancing strategy, they will have similar models, and they will try to open source it to just level the ground to kind of limit their advantages. So then you see a thrive of all those open source models again until the next breakthrough, Sora being or the other things. So I see that kind of small cycle coming.
There's a variation of that play, which is, even for the closed model guys, if you are the number 2, number 3, maybe you should open source it.
Exactly,
right?
that's what's happening. Mistral,
Right. And then, Google open sourced a little bit, not quite. I think the Auditing podcast, I remember people said, Google should have just open source everything to protect their search revenue.
Which is insightful.
Which is an interesting statement to make. Yep. Anything else on your side?
These are probably not too special. Probably that's what I have. But I'm happy to talk about other aspects if you have.
No, I think this is pretty good. We talked about a variety of different benchmark, right?
Yep.
Open versus closed. Clearly there is, because of AI, it's not a surprise to anyone. The interest in AI is skyrocketing, not just from paper point of view, publication point of view.
Yep.
Here's the data to show that the AI projects from 2011 to 23, right? Skyrocketed in the last few years. Right now there are 1.8 million AI projects. That's a lot of data, by the way, for Microsoft.
They can use that open source project to train a better model. So data is still.
I wrote up an article the other day, a few weeks ago. I said there are 3 acquisition/partnership or some biz dev kind of the activities that's going to impact or give a tremendously positive impact to Microsoft. The 3 things. Number 1 was this GitHub acquisition. I don't think Satya necessarily, or I don't think he realized this is the impact to AI at this level.
Probably not directly.
Not directly, right? But give him some credit. He saw something at least. The other thing is obviously Microsoft partnership with OpenAI or investment in OpenAI. And then the third thing is actually, it happened quite recently, the inflection. And that one hasn't been talked a lot in the open. I'm not going to get into details, but coming back to this AI projects, this is a number of stars, and it skyrocketed literally in the last 2 years. 12 million stars. From just 2 years ago, it was only 4 million stars. So it shows that people just have tremendous amount of the interest. So I see you just pulled out the high-level takeaway. Anything else?
There's something I want to mention that I think is very interesting. Also, similar observation last year is that I found that the transformers scaling, data scaling, compute scaling, and then they get MMLU like 90% performance, which basically means that the model understands the world, pretty much. So that has been a great improvement. At the same time, we see that benefit or improvement from that area, say in terms of text, being expanded or borrowed to other areas. So remember last year, we started to see that robotics started to also benefit from this improvement. So your language model does not just output text. With the same word knowledge, probably can also output some instructions for those robots. So we start to see also huge improvements from Google's like PaLM-E model for instructing the robots to actually do like 3D composition, manipulation of objects. So that's something I didn't expect, but turns out to be working very well. And then something more technically closer is that we start to see the text word understanding, the foundation model being borrowed to use to fine-tune some multimodal models like for understanding the images. And then the fine-tuning actually involves only a slight bit of training cost. That basically means that largely the word understanding, for example, on a door there's a handle, or if you want to get through the door, you have to open it through certain ways. All those knowledge has been inside the language model itself. So I would say this benefit or improvement from transformer, from text, has been a big benefit to all the other areas as well, and we're expecting some more things to come. Also, like Sora. Sora is actually also partially based on transformers. So its world knowledge also partially from the transformers. So I'm looking forward to see kind of more improvements there.
Yeah. I think we are going to getting to the close of this session, and hopefully people like our discussion. And then depending on the comments, the request, we may get into some of the image model, the video model,
Yes.
right? And then also some of the things we didn't discuss today yet is about the investment, right?
Yep.
And I'll close it with one thing: regulation. I have a neighbor who's a big lawyer of a big firm. She gave me a lot of the education on the regulation side. She mentioned to me that at this point, we don't have like a nationwide AI laws, for a lot of reasons. Maybe some of that is political reason or whatnot. Yeah. But at state level, there are already 22 states having AI laws. That's actually pretty interesting. Some of that has to do with, for the HR, right? If you leverage the AI, you cannot do X, or you should have this best practice or do that, so to avoid a bias or things like that. This report definitely shows that the number of AI regulations in the United States increased, dramatically, right? So that is an interesting tidbit from the report too.
Hopefully to also mitigate people's concern last year, largely about if AI will replace all the jobs, AGI will this kind of destroy humans. So I think largely we need to see those social improvements or regulation to catch up.
So perhaps I just use this as the last discussion point. You have been doing programming for a long time, right? From school, work at Databricks. By the way, you have been at Databricks for
6 years.
6 years, and then when you started at Databricks, how many people?
120, 50 something. Yeah.
And then roughly how many people? 8,000 people? 7,000 people. So from 150 to, so what a run, right? So you have been working at a star high-tech company in Silicon Valley in the last 6 years, right? And clearly you benefit a lot from being a good programmer, being a good computer science student,
yeah,
right?
Thanks to my background.
So that's great. My last question or the last discussion point is, what do you think? With all the AI, right? The benchmark for programming probably is going to get better and better, and at some point maybe even getting closer to human level.
Yep.
Do you think people should still learn programming, and why?
I think they should learn for sure. Is your question more coming from assume that will be replaced?
Look, you already know enough about programming. You're not going to unlearn it, right, for the next 5 years.
Yeah.
That's clear. But for people who are still like early in the career, right, junior, or maybe even not even in the career, in the college, or even younger kids, like, what's the benefit of learning or spending a lot of time learning programming? I'm just curious. What's your take?
That actually reminds me of a funny, not a detail, actually a major aspect that Zuckerberg mentioned in the Llama 3 training. So initially, for Llama 2, they trained the model without much of a coding data. They think that I just want to build a chatbot. Why I need training data? And then turns out the model is not doing well in coding for sure, because there's no training data for code. Also, it's not doing well in reasoning. So then in Llama 3, they try so hard to get a lot of coding data to be trained. And then that not just benefit the coding, but all the other aspects, like instruction following, reasoning capability. So my take is kind of similar to that perspective. Probably you don't have to be the expert for coding, but coding actually teach you how to think about things, how to do abstractions, how to reason about computers, how to do data movements. I think all those computation methodology actually helps a lot for people to learn. So probably then the difference is you still have to learn have to learn coding if it's a short answer. But a long answer is that probably you will take a different approach to learn it in the future. Instead of learning how to code a complete program all by yourself, line by line, probably in the future you are assisted by a program. You just need to know the essential piece of it, the methodology behind it. So that's my take for if people should.
Interesting. So 2 points. One is the fact that the coding data benefited the Llama 3 model training.
Yes.
That might be the same reason why in the
Human
future
also need to learn.
humans should learn coding.
Exactly.
Right. That's actually a very good point. And then the other thing is, your view is people should still spend a lot of time learning, but how you learn it may be different.
Exactly.
Right. It's almost like these days when I write an email or write something, the grammar check or the spelling check is already there.
Yep.
So in the past, depending on the nature of the article, I may need to, give someone else, hey, can you proofread it, right?
Yep.
Now, have a little bit peace of mind, without showing to anyone that it's reasonably correct from the grammar point of view, from the spelling
Exactly,
point of view.
and it would be a lot faster. For me, it took like 6 years to have this computer science undergrad and master's. Probably in the future, with the help of all those tools, you're doing it in 6 months or even 6 weeks, right? So it would be a lot more pleasant experience for people.
Okay, I really like that way of thinking. Thank you for coming to discuss this paper and then, beautiful campus at Stanford. And then I think, I had a good time and learned a lot.
It's a great pleasure and a lot of fun talking about it.
Thank you everyone. This is the Bite into Future. More interesting things to come. Bye.
Bye.